For this problem, we're going to use a rule of inference called modus ponens, which says that if we're given that P implies Q, and we're given that P is true, then we can conclude from that that Q is also true. That can become a new given in our proof. Okay. So actually there's two parts here. Part A says, suppose P implies Q and Q implies R are both true. So those are givens. And prove that P implies R is true. Okay. And, well, we know that if we have a goal of P implies R, then we can take P as a given and R as a goal. And we can bring down our other givens. And now looking at our givens here, we have P implies Q and P, and that's precisely modus ponens, right? So from that we can conclude Q. And again, bring down our other given and goal. And now we have another modus ponens right here. Q implies R together with Q. From those we can conclude that R is true. And that gives us our goal. So let's try to write out that proof. We will, first of all, suppose P. And then, since P is true, right? We don't usually write the is true part. We'll just say since P and P implies Q, it follows that Q is true. And let me just make a note here that follows from modus ponens. Normally you wouldn't write that. It would just be understood, but as we're learning, I'll indicate that here. And then in the next step, we had Q and Q implies R, and from that it follows that R is true, also by modus ponens. Okay, and that's the proof, but let's have a little summary statement here. Therefore, P implies R. Okay. Now, I've actually broken another rule of proof writing here, which is that you're not supposed to sort of use this logical notation of proof. The reason I'm making an exception here is because the statement we're proving actually is written in terms of logical notation, so it's okay to use it in the proof here. Okay. Normally we'll try to avoid it if possible. All right, part B looks a little more complicated. Suppose not R implies P implies not Q, and prove that P implies Q implies R. All right. So we have our given and goal, and okay, well, we can replace that given by that goal by a given of P and a goal of Q implies R. Bring down our other given, and nothing is too apparent from these two givens, so we should look at our goal and work with it. And we can well, we could either use direct proof or proving the contrapositive. So we could either bring Q over as a given or the negation of R as a given. And I'm going to choose negation of R because that appears here in one of my other givens. Right? So those can go together in the next step using modus ponens so that we can conclude P implies not Q from here. And bring everything else down. And finally, modus ponens again. From P and P implies not Q, we're allowed to conclude not Q. Okay, so how are we going to write this one up? Let's see. Well, first thing we did was to bring the Q down here, the P down here as a given. So we can say, suppose P, just like in part A. And then in the next step, we decided that we were going to prove the contrapositive of Q implies R, right? So we should tell our reader that's what we're going to do. We prove the contrapositive of Q implies R. And for that, we're going to suppose that the negation of R is true. And then Okay, so that brought us to here, and then we used modus ponens to combine a couple statements. So since the negation of R and this complicated statement are both true, it follows that P implies not Q, right, by modus ponens. And that brought us down to here, and then we use modus ponens again. All right, so since we have P and we have P implies not Q from the previous line of the proof, it follows that negation of Q is true. Okay. Again by modus ponens. Okay, so well, that finishes the proof, but we should summarize what we've done. So if you go back up to this line, we were trying to prove that Q implies R, which we've done now. So therefore, Q implies R. And we were doing that because at the end of the day, we were supposing Q and concluding that. And that proves that P implies Q implies R, okay, which is our original goal. And now we're done.